Hello everyone, thank you for joining me in this particular video. And in this particular video, I'll be talking about the specific ways to create models in TensorFlow. That is the sequential, using the sequential API, the functional API, and the subclass API. So I'm still going to use the previous architecture which I used in implementing the convolutional neural networks, and I'm going to create that architecture in all the three ways, that is the sequential, the subclass, and the functional API. So this is the architecture which I'm using for the convolutional neural network. And as you can see, there are three ways. So the first way we want to handle is the sequential API. So this is appropriate. This is usually used when you are using maybe a single input, single output kind of architecture, since it's not flexible and hence it cannot be used for multiple input or multiple output architectures. So in this API, you stack one layer on top of another to create a stack of layers so it's like a straightforward flow of layers from the single input to the single output. So the way you create it is by creating the sequential, initializing the sequential constructor. Then within the sequential constructor, you stack you stack the layers that you want within the sequential API. So that's how I have used it to create the sequential. I've used it to create the model. In this case, I initialize the sequential constructor. That's from here. Then within the sequential constructor, I call the layers within it. So when I create the model now using the sequential constructor, we get the model. Now once we've created the model, we can display the contents of the model using the summary. So in this case, we see the contents of the model using the dot summary, of course considering also the output shapes, the name of the layers, which can be modified using the name argument, and also the parameters, of which for certain layers such as the max pooling and the zero padding, since they are not trainable variables in such layers, the parameters are 0. So all the trainable parameters are only exist for those layers that have trainable parameters, that is adjustable weight that will be adjusted during training of the model. So apart from using the passing all the layers within the sequential constructor, you can also use the .add method, where you create an empty model, then you add one layer on top of another as you continue. So this is usually very important when you want to understand the flow of the model as you create it. Now if we view the summary, we'll see that we see the layers that we've added using the .add method. So but essentially this is the way we can use create the model using the sequential API. So the second API, which is one of the most recommended as it's considered industry worthy, is the functional API. So functional API got its concept from the directed acrylic graph of layers. So in this case, we assume that the layers of the model is kind of like in form of a graph, such that now you build the layers as nodes. So for instance, if we want to create the model for the architecture using the functional API, we first of all initialize the input as a node. Then on top of the input, we create a new node by calling a layer on the previous node. So to create the next node, we call a layer on the previous node. And so, but if you want to, let's say, call a layer on maybe multiple previous nodes, use the concatenate method in the keras function. So in the keras there's a function known as concatenate, which can be used to concatenate previous nodes when you want to create a new node on the previous nodes. So that's how we can create multiple input, multiple output architecture using the functional API. So in this case scenario, when we create the input node here, then so on the input node, when we want to create a new node, we call a layer on the input node. So this is how we'll call a layer on the input node. So again, on the layer that has been created, we call another layer on it to create the next node, So we do like that until the whole graph is built. Remember, in the functional API, the architecture is considered like a graph of layers. So once the complete graph is built, you can now create a model by specifying the input and output in the graph of layers. So in this case, when we create the model, now we can also view the summary using the functional API, and we see that the count parameters of the functional and the count parameters of the sequential are equal. Hence we've created the same model using both the functional API and the sequential API. So when we assert, we see that it's really, the parameters are really the same for the two. So the third API is the subclass API, where you implement everything from scratch. So this is the kind of API that's mostly used for complex out-of-the-box research use scenarios, especially those research papers which are being presented in the neural IPS, for instance. Those kinds of neural architectures are built using the subclass API. So in this case, so I just implemented like almost everything from scratch in order to show you how flexible and how complex this API can be used. So in this case, I assume I took the three repeated patterns of the padding, convolution, and max pooling, and using this list of boolean, I could activate which layer was active and which one was not. So this one was the try block, which consists of the zero padding, the convolution, and the max pooling. And then this one is now the linear layer. Of course, I decided to create everything from scratch so that we can better understand how the subclass API is used for building everything from scratch with out-of-the-box use cases. So in this case, now when I pass this list, for instance, in this case, the zero padding is deactivated, only the convolution and the max pooling is active. So when by default, all the three are active. So when I don't pass this one, it should take the default arguments where it's a list of true for all the three layers. So it's for the zero padding, convolution, and max pooling, all of them are true. So I built all the layers using this out of the box scenario. So after building it, so one thing we have to understand is that since I did not really specify the input in our first layer of the try block architecture in the subclass API, in this part there's no specification of the input. So essentially, because there is no input, the model cannot, you cannot view the summary of the model. In that you cannot view the details of the model. So an out of the box way of doing it, or like a hacking way of doing it, is like creating a dummy function which will create a kind of a functional API, and then you can using that kind of API you can view the summary of the subclass. So essentially, building the model, the model can only be built in that only the weights of the layers can only be realized once the input has been passed to the layers. So once, if the input has not been passed to the layers, the weights of the model of the layers cannot be realized. Hence, you cannot view the contents of the model. So these are a really crude way of like realizing the weights of the models by creating a dummy where you specify a dummy input, and then you create a dummy model where you can view the contents of the model, where we see that the trainable parameters are the same as in the functional API and the sequential API. So this is the same model created using the subclass API. But anyway, this one ought not to be in your when you create your model. So it should only be this one, and then you specify the output shapes. Yes. So we've seen the three ways of creating models. That's using all the three APIs, and I hope you've understood deeper how the three APIs work and how they can be used in certain complex architectures and topologies, and also in multiple input, multiple output models. So thank you. In the next videos, we'll talk about the types of CNN architectures and how we can implement such as the VGG16, the ResNet, and the AlexNet. So thank you for watching.